Here we're asked to sketch a graph where we've got a pretty complex and horrible sort of a function. So it's a good idea for us to work out some sort of strategy for doing it. First of all, this is in the form of the e to the x graph. So you know it's going to look something like this. Now there's no vertical translation here, so therefore we know it's not going to go below the x-axis. So it's going to be that approximate shape, but we're just not sure exactly the finer details about this graph. To find out more information, labelling all intercepts and stationary points, we want to think about the intercepts. Well, as I said before, there won't be an x-intercept because it's going to follow this exponential pattern and it hasn't had a vertical translation. So I'll need to find the y-intercept, which is where x equals 0. As far as a stationary point goes, any stationary points, and I don't know if there's 1, 0, 763 of them, I need to make sure I'm sure that the stationary points will be where the derivative equals 0. So here's what I'm going to work out, and here's the basic shape that I'm looking for. So let's get started. First of all, my y-intercept is where x equals 0. So therefore, y, or should I say more correctly, f of x, f of 0, equals e to the 0 cubed. 0 cubed is still 0, so it equals 1. So therefore, my y-intercept will be at 0, 1. And I'll just put that in a box so I'm sure of it. Now let's find the derivative. dy dx equals, well, not very nice, but I could say that f of x equals e to the u, where u is x cubed. So therefore, it looks like I'm going to use the chain rule. Now, in this case, I'll call u x cubed, so therefore du dx is 3x squared, and y equals e to the u, so therefore dy du equals e to the u as well. Here's my golden pieces of information, so let's turn them into a solution. So therefore f dash of x using the chain rule will equal du dx by dy du, which equals 3x squared times e to the u, and u is x cubed, ex cubed. So therefore it equals 3x squared e to the x cubed. Now we need to work out where this is 0. So I need to say this is 0 and solve this issue of where our turning point is. Now the big trick here is we've got an x out the front here, and I know that if I multiply anything, doesn't matter what it is by 0, I'm going to get 0. So therefore I also know that x equals the 0 at the stationary point, because if I put a 0 in here, everything's going to equal 0. Any other number, and this will actually equal a number other than 0. So I know that x is 0 at the stationary point, so this point 0, 1 is not only the y-intercept, but it's also the stationary point, which means my graph is going to look something like this. Here's x, here's y. It's going to come up the way an exponential would, but it'll even out to a stationary point at the intercept and then go up. And this point here will be at 0, 1. So I've got my stationary point, which is what I want. I've got my y-intercept, which is what I want. This means I've answered this part of the question and this part of the question, and I'm going to have a happy examiner. It looks a bit ugly there.
If you found this video helpful, please subscribe or like. Thanks.